Assalamualaikum and a very good day class. So now we are in the next subtopic which is still under first order ordinary differential equations, but we'll go how can we solve first order ordinary differential equations in terms of linear equation. Here class, by the end of this chapter, you should be able to determine and find the general solution of the linear equations. So, first thing that we need to know is what is linear equation of ODE. Actually, you have learned about this in week 1 video. Linear equation is a one type of ODE that occur frequently in application problem, and it has a general form of dy over dx plus py equal to q, whereas here p and q are functions of x only. And this equation, we call it as linear equation since we can see here y and also its derivative dy dx are the first degree. That is why here it is degree 1 and also dy dx is degree 1. And if you see here, there is no multiplication between y dy dx with its dependent variable because p and q here are functions of x only, so that it fulfills all the condition about linear equation of ODE that you have learned in week 1. But to solve this one later, you need to understand about this equation dy dx plus py equal to q, because before you solve using this method, you need to write your equation into a general form of this one. How do we know that the equation, we can call it as a linear equation? An equation is said to be linear if it has the form of ax dy dx plus bxy equal to cx. Here the multiplication involving dy dx is only function of x. Multiplication involving y only function of x as well, and also it is equal to some function of x, where here ax, bx, and cx are constants or function of x or constant. And to solve this linear equation, we need to transform this one into general form. dy dx plus py equal to q, where is p and q also function of x. If I want to write this one in general form, means that I need to make a coefficient of dy dx equal to 1. So now I have a of x dy dx plus b of x y equal to c of x. So to make this coefficient equal to 1, I need to divide the whole equation here with a of x. I divide here with a of x. This one divide with a of x, and also this one we divide with a of x. This one will got equal to 1, means that I will have here dy dx plus b of x over a of xy equal to c of x over a of x. And class, if you see, now the coefficient of dy dx equal to 1, which is in this form, and this one some function p, which is p is a function of x times y. So here this one actually is p of x, and then we have equal to q, means that this term is q of x. So by writing our equation in this form, we have write in terms of general form, whereas here p equal to b over a and q equal to c over a, and here we leave the coefficient of dy dx equal to 1. So class, we go to this example. Identify whether the equation is linear or not. In this case, we know general form of this equation, of the linear equation, is dy dx plus e of xy equal to q of x. Our first step here, we need to write this equation in this general form. I can rearrange this equation. I will have here tangent x dy dx equal to x squared sine x minus cos x multiplied by y. And then this term, actually it is in terms of some function of x multiplied with y. So I can move to this side. I will have here tangent x dy dx plus cos x y equal to x squared sine x. And then class, I need to make the coefficient of dy dx equal to 1. Means that I need to divide all for the whole equation with tangent x. Okay, so this one also we need to divide with tangent x. Means that here I will have dy dx plus cos x over tangent x times y equal to x squared sine x over tangent x. So class, this is general form of linear equation, means that this equation actually it is linear equation. And then next class we go to this example. Identify whether the equation is linear or not. In this case, directly you can see this one we have y to the power of 2. Here you have y multiplied with dy dx. So it is not fulfill the condition the condition of linear equation. In this case, we have a multiplication of the dependent variable, and also its dependent variable is multiplied by its derivative. So in this case, it is nonlinear ODE. Now class, when we have the equation in terms of linear equation, there are specific methods to solve that linear equation of ODE. These are the steps to solve linear equations of ODE. The first step, it is very important for you to rearrange the equation in the form of dy dx plus pxy equal to qx. Means that you need to write your ODE in terms of general linear equation. And then based on this one, you can identify P and Q. Means that you can get step number 2, get Px and Qx. And then when you got this Px, you can solve for P, which is here. Solve for the integration of P dx. That is, you need to integrate P without constant. Remember here, without constant. Once you integrate P dx, step number 3, you need to calculate the integrating factor. The integrating factor is given by rho x, which is equal to the formula of exponential and the integration of P dx. That is, this part actually comes from step number 2. Once you got the answer in step number 2, you can find the integrating factor by, by substituting integration of P dx in this formula. And then we can rearrange the equation in the form of d dx d rho y. This one is integrating factor from step 3. And also this one is integrating factor from step 3. Means that rho times y and here rho times qx. Once we got this one, we go to the last step. We integrate equation in step 4 with respect to x. That is, finally you got this solution. Rho y equal to integration of rho q dx. That is, for this part, if we have a step number 4 here, d dx rho y, which is equal to rho qx, we can actually move this dx to this side. So we have d rho y equal to rho qx dx, and then here we integrate both sides. We've got here rho y equal to integration of rho qx dx. So we integrate this one. Finally, you will got a function of y, which is rho. You can move again to this side. Plus, you have learned the theoretical part of the linear equation. So we have here the problem of solve y prime minus 3y equal to 6, which is here. This one we can write y prime, actually it is 3y dx minus 3y equal to 6. In this case, before we use linear method, we need to check whether this equation is linear or not. There is no multiplication with the dependent variable and the degree of this dy dx is 1. And you see here minus 3y, which is for y. The degree of this y also 1 and no multiplication with any dependent variable function. Here, in this case, we can write this one in terms of, which is step number 1. We need to write in terms of dy dx plus p of x y equal to q of x. When we have this kind of equation, you can see the coefficient of dy dx now is 1. Okay, so it is in this form. Plus pxy means that here this negative 3 is the value of px. Is multiplied by y, and then this side is a q of x. Means that here our differential equation is already in this form, which is dy dx plus negative 3y equal to 6. Number 2, we need to identify px and qx. In this case, we can see clearly our p of x equal to negative 3 and q of x equal to. And then we need to integrate p of x dx. So here we will have integration of negative 3 dx. Remember, integrating this one, we integrate without constant. So when we solve this one, we will have here negative 3x. And then class, for step number 3, we need to calculate the integrating factor. Integrating factor is given by rho of x equal to exponential integration px dx. This one actually you got from this step. Means that here integration of px dx is negative 3x. So that our integrating factor here is exponential of negative 3x. So that this one you just substitute with what you get in step number 2. And then step number 4, we need to rearrange the equation in the form of d dx, which is here rho y, and then equal to rho q of. So class based on this we'll get here d dx. Rho here actually is given in step number 3, which is exponential of negative 3x multiplied by y equal to exponential negative 3x q of x. And q of x we got here is 6. So you need to multiply with 6. Means that we will have here d dx exponential negative 3xy equal to 6 exponential negative 3x. For step number 5, we need to integrate both sides. So we already have previously d dx exponential negative 3xy equal 6 exponential negative 3x. In step number 5, you have learned that you need to integrate both sides. So we will have here integration of this. Means that here when we integrate this, we'll have integration of d exponential negative 3xy equal to integration 6 exponential negative 3x dx. And solving this one, you will got here, this is integrate and differentiate, you will got this in this bracket as your solution. That is, you will have exponential negative 3x times y equal to, when we integrate this part, you need to refer to mathematical formula book. How can we integrate exponential function? In this case, when we integrate exponential function, we will have here the sig is constant, exponential of negative 3x, and this one you need to differentiate this, which is will be divided by the differentiation of this, divided by negative 3 plus c. So when we simplify this, we'll got here equal to negative 2 exponential of negative 3x plus e. When we rearrange this one, we make this y as subject, we will have here y equal to negative 2 exponential of negative 3x plus c, which is all this divided by exponential of negative 3x. By using exponential law, we will have here negative 2 exponential of negative 3x. Here, it is divided by this, so minus negative 3x plus c. This one we put above, which is become exponential of, there is no minus here, so exponential of 3x. For this one, you can see negative 3x minus minus become plus, so we can cancel out. So you have here equal to negative 2 exponential of 0 plus c exponential of 3x. And this one, we know when we use calculator, exponential of 0 is 1, so it is equal to negative 2 plus c exponential of 3x. So this is the final solution of this problem. For this example, what you can see here, our solution is in terms of C. So this one is in terms of general solution. Why it is in general solution? Because in our problem, there is no initial value. But class, when we refer to that, to the next example, we can see here we need to find the particular solution of that differential equation, which here satisfy the condition y0 when x equal to 1. Here give us initial value. Means that for this one, you need to find particular solution. The first step here, you need to check whether your function here is linear equation or not. In this case, step number 1, we need to write dy dx in terms of dy dx plus pxy equal to q of x. If you see our problem here, we have dy dx plus 1 over x multiplied with y equal to 1. So the coefficient of this dy dx is 1. Fulfill this general form, and then you can see this is function of x multiplied with y, means that this term is p of x, and this one is q of x. So this is general form of our differential equation in terms of linear. Number 2, clearly here our p of x equal to 1 over x and q of x equal to 1. In this case, next we need to integrate p of x. We need to integrate p of x dx. So here you need to integrate 1 over x dx. Integrating this one, you need to refer to mathematical formula book. Here, when we integrate 1 over x here, we've got ln x. Remember, integrating here is integrate without constant. And step number 3, once we got here the integration of px dx, you need to find the integrating factor, which is given by rho x exponential equal to exponential of integrating px dx. This is integration of px dx, which is given by ln x. Means that when we solve this one, you just substitute here integration of px dx with this ln x. So you will have here exponential of ln x. In this case, you can see that this one is in terms of exponential of ln x. You can simplify this. We can cancel our exponential and ln, we can get here x, just x. So the next step, step number 4, what we need to do is we need to find d dx rho y equal to rho q of x. So in this case, our rho is given by x, and then our q is given by 1. Means that here d dx equal, in this bracket, rho, which is x, x times y equal to x times 1. So you will have here d dx xy equal to x. And our step number 5, we need to integrate this both sides. So we'll have integration of d dx xy equal to integration of x. And this one move to this side, so we'll have integration dxy equal to integration x dx. In this case, this one we integrate and differentiate, we can cancel out with just in this bracket xy. Integrating this one, you will got here x to the power of 2 divided by 2 plus c. Okay, and in this case, we can write here our y equal to, we can move this x to this side, so we'll have x squared over 2x plus c over x, which is we'll have here x over 2 plus c over x. But class, this one is not yet finished, because what we got here is a general solution. We have initial value problem, which is given to us x equal to 1, y will be equal to 0. So in this case, we need to substitute y and x so that we can compute this c. So we will have here, actually based on this, we have y equal to x over 2 plus c over x. When x equal to 1 and y equal to 0, when we substitute in this equation, we will have 0 equal to 1 over 2 plus c. And then solving this one, we'll got c equal to negative 1 over 2. You cannot just leave your answer like this, because what we want here is a particular solution. Particular solution means that we want a function of y, so that c equal to negative 1 over 2 means that we have here y equal to this x over 2 plus this c, substitute with negative 1 over 2 means that minus 1 over 2x. So this one is the final solution for this problem.